First, we're going to go over some vocabulary. And this kind of is hand in hand with yesterday. That's why yesterday was 1-3A, today's 1-3B. So, assuming you have mastered everything that I told you yesterday. Now we're moving on. Adjacent angles. I told you yesterday we talked about what adjacent means. So, it means sharing a side, right? Two angles in the same plane with a common vertex and common side. Ew, it doesn't fit. Side. But no common interior points. That's important. No common interior points. So that means the angles don't overlap. So they're adjacent, but they don't overlap. It's just two angles next to each other. Adjacent angles. Next up is linear pair. If we look at the root words here, linear, the base word there, line, and then pair is just pair. So if we have a line pair of angles, maybe a pair of angles that make a line, right? So a pair of adjacent angles whose non-common sides are opposite rays. That's a very complicated way of saying what I just said. Two angles that make a line. So you have a straight line and a ray that divides it into two angles. That's a linear pair. Straight line with a ray that divides it into two angles. A line pair, a linear pair. And then complementary angles is next. Complementary starts with a C. So does the word corner, starts with a C. And when you think of a corner, maybe you would think of 90 degrees, because a corner, right, 90 degrees, 90. So, two angles whose measures have a sum of 90 degrees. They don't have to be touching. There's just any two angles. If they add up to be 90 degrees, then that makes them complementary. So, it could be 30 plus 60. 30 degrees plus 60 degrees. Those would be complementary. It could be an 80 degree angle plus a 10 degree angle. Those would be complementary. Any two angles that add up to be 90 degrees are complementary angles. So complementary starts with a C, like corner, and when you have the little box in the corner, it means 90 degrees. So it's me like connecting the words for you. Complementary goes with 90, corner. Supplementary starts with an S, and supplementary, think of straight line. Straight line starts with an S. And a straight line has a measure of 180 degrees. Or a straight angle does. So 180 degrees. So then two angles whose measures have a sum of 180 degrees would be supplementary. So 50 plus 130. Those angles would be supplementary. Or 105 degrees plus 75 degrees. Those angles are also supplementary. So any two angles whose measures add up to be 180 degrees are considered supplementary. So remember, supplementary, S, straight line, 180. Complementary, C, corner, 90 degrees. Okay? Because I know those can be confusing because you know, getting them which one's which. C or S. Look at the first letter. Vertical angles. Now, vertical angles are something I will say all year long. They will not go away. So, you know, in some classes, sometimes you have that one piece and it just won't go away, like factoring during algebra. It just never goes away. Doesn't go away in Algebra 2 either. But vertical angles will not go away. So go ahead and just learn what it means now. Save yourself the headache. Non-adjacent angles formed by two intersecting lines and they're congruent. So, well, I'll write that in a second. Vertical angles, okay, here. Vertical angles are congruent, meaning they have the same measure. So they're going to be congruent. And you can recognize them because the lines make an X, and so then the opposite angles are equal to each other. Those are the vertical angles. Each X, each pair of lines that make an X, have two different pair of vertical angles. Just to keep it simple looking, I'm not really going to mark all of them in here. Just want you to see that. Okay. So these two, and it's a V, right? The vertex, the V with the vertex, and the V with the vertex, they make vertical angles. So here, these are across from each other, so they're equal. And these are across from each other. I didn't mark them because it just starts looking crazy. Those are also equal to each other. Not all four of them, but there's two pairs of congruent angles. So these two are congruent, and these two are congruent. When you have the X shape, it's two vertical angles, because it's also two V's, right? The V going one way and the V going the other way. Vertical angles are congruent. All right, so that's your vocabulary for today. So now we're going to practice a little bit. Tell whether the angles are only adjacent, adjacent and form a linear pair, vertical angles, or not adjacent. So you have four options here. I'm going to give you a pair of angles, and you have four options to describe them. So angle 5 and angle 6. Here's angle 5, and here's angle 6. So, how would you describe them? Are they only adjacent? Are they adjacent and form a linear pair? Are they vertical angles, or are they not adjacent? Are they vertical? Do you see an X shape in the highlighted green part? No. Are they adjacent? Adjacent means they share a side. Yes, they are adjacent. So are they only adjacent, or are they adjacent and form a linear pair? Yes, there's a line pair going on right there. So, adjacent and linear pair. Okay, next one. Angle 7 and angle SPU. So here's angle 7 and SPU. There's the two angles, the blue one and the green one. Are those adjacent? So if we look back at the definition of adjacent angles, two angles in the same plane with a common vertex and common side, yeah, all that matches up, but no common interior points. The whole green angle is inside the blue angle. So everything about the green is common with the blue, right? So they cannot be adjacent angles. They're not next to, one is inside of. All right, so then only adjacent? No. Adjacent and linear pair? No. Are they vertical angles? No. No. So they have to be not adjacent. That's the only option, right? Not adjacent. All right, so angle 7 and angle 8. Are those adjacent angles? Are they next to each other? They share a side? They do not share a side, right? So only adjacent? Nope, that's out. Adjacent and form a linear pair? Nope, not adjacent. Are they vertical? Not quite, right?
No.
Because it's not an X, right? See, like, see? If that's the line right here, that's not an X. This would be an X. 5 and 8, those would make an X, not 7. So if you could shift it down to the right, then it could be the bow tie shape. Right now it's kind of squished. Yeah. All right, so that is also not adjacent. All right, last up is 5 and 8. Oh, I gave that away, didn't I? Didn't mean to do that. So what's that? They're vertical, because there's two V's, right? There's the two green shapes are both a V, and they're opposite from each other. They share the end point. They make an X. It's a bow tie. It's all the different ways I could think to say that. Vertical angles. All right. Okay, so we're going to find the measure of each of the following. The complement, C, of angle M. Complement, C, corner. Corners are at 90 degrees. So that means they don't have to be next to each other, but this is just a little visual representation here. Together, it's going to make 90 degrees, and it's going to make a corner. So I'm looking for this angle. So if I did 90 degrees minus 26.8 degrees, then I would get 63.2. And that would be the complement of angle M. Because together, they would make 90 degrees. So if complement is 90, supplement with the S for a straight line. Straight lines or straight angles have a measure of 180 degrees. That looks like I said greater than. All right, so supplement of angle F. Here's angle F. That would be a straight line. It would end up looking like that. So I'm looking for this angle, and I know the total is 180 because a straight angle is 180 degrees. 180 minus 116.5. I don't know who created this with the decimals in it because it seems unnecessary. Would give you 63.5 degrees. Don't forget to label it. 63.5 what? Degrees. We're talking about angles. All right. I'm going to do some more of that. I'm going to go ahead and skip the first two because it's the exact same question, last two that I went through, and I would rather you have more time to work on your assignment. But these next two, 2 and 4, if I want the supplement, remember supplement, straight angle, 180 degrees, of angle D. Oh, and look at angle D. That doesn't look very nice, does it? But without looking at angle D, we know it's going to be 180. And what are we going to do with the 180? That's the total. If we take away the one we know, angle D, what's left over is its supplement, right? I'll just put supplement. So if we just plug in what it says there, x plus 30, it's not that bad. Now I can distribute that negative sign into the parentheses. 180 minus x minus 30 equals the supplement, which is what I'm asked. All I can really do is combine the numbers. That's it. I can't solve this for x. That's called leaving it in terms of x. And that's fine for this problem. That's all I'm going to do. All I can do is put the 180 minus 30. 180 minus 30 is 150. And leave it as minus x. That equals the supplement. So I'm done. So 150 minus x degrees. So it looked real scary, but once you just like treat it as a chunk, it's not that bad. And then we're going to do the same thing for the complement of angle D. Complement of angle D, complement, corner, 90 degrees. Okay, so that tells me I'm starting with 90. 90 minus something is going to give me the complement. And so what I'm going to do, I'm going to take that x plus 30, plug it in. And then do the same thing. All I can do is distribute the negative and combine like terms. I can't solve because I don't have enough information. And that's fine. We're going to leave it in terms of x. So 90 minus x minus 30 equals the complement. So all I can do is say 90 minus 30 is 60. So 60 minus x degrees is the complement of angle D. Okay. So in what instance could you have congruent complementary angles? I mean, there's more than one, but just like, what's a situation that would be congruent, meaning the same, and complementary, meaning add to 180. So 180, complementary is 90. What am I doing? Add to 90 degrees. So if I have two congruent angles that add to 90 degrees, what do their measures have to be? Well, I'll just say 90 and divide it by 2, right? It's 45. So if I have two angles that are 45 degrees, I could have a right angle and then bisect it. If I bisect a right angle and make it 45 and 45, that situation is two congruent angles that are complementary. Or another one is that what if I could do vertical angles, because it didn't say they have to be adjacent. And I could say this is 45 and this is 45. Or I could just have two angles that are completely not making up anything else and just be 45 degrees each. So that is congruent complementary angles. All right, so now we're going to do some solving. Find the value of x. So looking at number 6, and I have a diagram. So I know I want to label my diagram, but before I do that, looking at this picture, what do I know about angle 1 and angle 3? They are the same. Why are they the same? Because they're right across from each other and they're the same because they're vertical angles. Yes. So I'm going to mark this one to be the same as this one. What about 2 and 4? What do I know about those? They're the same too. I'm going to mark that one with 2 lines like this.
James, are you working?
All right, so even before I've started the problem, just by looking at the picture and knowing their relationship, I know it does that. So the measure of angle 1 is 2x minus 4. So I'm going to put that in the picture. 2x minus 4. The measure of angle 3 is 6x plus 1. Because I've already marked them to be congruent because they're vertical, I have an equation already. I can say that 2x minus 4 is equal to 6x plus 1. Because they're vertical, they're equal. And then I just need to solve that. It's a pretty basic solving equation. I'm going to get like terms together. I want to get my x's to one side. To do that, I want to go with take baby to mama. The little one minus 2x. Move that one. So my x stays positive. If I move the other one, it doesn't matter. I'll just have a negative and I'll deal with it later. Cancel out the negative, the 2's. So now I have negative 4 equals 4x plus 1. I want my non-x's on the same side. So all my x's are together, and there's 4 of them. So I want my non-x's away from it. So that means I need to move 1. That's a positive 1, so to move it, I'm going to cancel it out by subtracting 1. And I can do the same on the left as well. That cancels. Negative 4 minus 1 is negative 5 equals 4x. So last thing I'm going to do is get x by itself. I can already tell it's going to be a fraction. That's not going to divide evenly, and that's okay. Because you know what? I don't have to do anything else with it. It just says find the value of x. So it can be a fraction. No big deal. Even if I had to do something else and plug it in, fractions are still numbers. So divide by 4. So negative 5 over 4 equals x. And that is all I was asked to do, so I am now done. For number 7, the measure of angle 2 is 4x plus 2. All right, so I'll mark that. This one is 4x plus 2. And the measure of angle 3, angle 3, well, I guess I'm not using this anymore, is x minus 1. I kind of thought it was going to be the other one. So don't just assume you know where it's going. Make sure you put it in the right spot. So we're using angle 3 again. So I crossed off where I had used it from the last problem, and I changed it to x minus 1. All right, so now I need to look for a new relationship because those are not vertical angles. They're not across from each other. Okay, but they are next to each other, and they kind of make a straight line, don't they? Right there, that line. And we know that lines add up to 180. So we could use that angle addition postulate that I told you about yesterday, saying the two smaller angles add up to be the larger angle if they're adjacent. So that's all I'm going to do. I'm going to say, oh no, what'd I do? This one, the green one, plus the pink one, makes up 180. So 4x plus 2 plus x minus 1 equals 180. Actually, I'm going to do it. So the green one plus the pink one equals 180. And because I put those parentheses there, I know they're not really doing anything. They were just for me to see as a chunk instead of all the numbers and letters and confusion. Makes it simple. So now I'm just going to combine like terms that are on the same side. So this is just putting them together. There's no opposite sign, nothing like that. So if I have 4x here, and then plus x, so 4x plus x gives me 5x. And then there's positive 2 and a negative 1. So 2 minus 1, that's positive 1, equals 180. So that got simple real quick. My next step is to get x by itself. So I need that non-x, 1, to move. To move it, I have to use the opposite symbol, or opposite operation. If I do it on one side, I must do it on the other side as well. So now I have 5x equals 179. which does not look very nice. I'm going to move it. I can't write anymore. So 5x equals 179. I'm not going to worry about the fact that it's not going to be a pretty number. I'm just going to go with it. Divide by 5. I have a calculator. It's no big deal. So x equals either 179 over 5 or 35.8. And there it is. Okay, so the last section is we're going to be labeling a diagram. And before I do that, there's a few things wrong with this diagram, or maybe not so clear. The A goes with that line, so B goes with the next line, and C goes with the next line to the right. So you might want to just relabel the B and the C, because it can be a little confusing. And then also F is on top of the dot, so you can't really see it. So this is F right here. Now it should make more sense. All right, so I'm going to take the information given to me in the instructions and put that in my picture. And then I'm going to see what it wants me to solve for. All right, so it says ray XA is perpendicular to ray XC. So if two lines are perpendicular, what does that tell me? Like, if they're perpendicular, what's their angle? It's the opposite of parallel, right? Parallels, and they never intersect. Perpendiculars, they intersect at a special angle, a right angle. What's the degree of a right angle? 90 degrees. Thank you. So this perpendicular symbol right here means 90 degrees. So on my picture, XA and XC meet at 90 degrees. All right, so that's labeled. And then it says XB bisects angle AXC. What does bisect mean? To cut in half, exactly in half, in the middle. Yes. So now I need to see, where is AXC? AXC, that's the same angle. And XB bisects it, so that means it cuts it exactly in half. So I could label that in my picture by drawing a line and then putting the two sections on it. But because I already know that angle measure, because the last thing I labeled, what's the measure of each?
45.
45 degrees. So I can put this as 45 and this is 45. Okay. Next is the measure of angle XCD is 32. So all I need to do is find CXD. I did not say that in the right order. The measure of CXD is 32 degrees. CXD is this angle. If that is 32 degrees, I can just label it as 32 degrees. So that's a pretty good start to my picture, right? I could also see, what else do I know from this without even looking yet? Do I see any angle relationships? I see that this angle AB is a vertical angle with this angle down here, FE. Does everyone agree with that? 45 degrees. So I could mark it as 45. And what else do I have? I have BC. Oops, I didn't mean to go red. BC is going to be vertical with GF. Does everyone agree that? They look pretty clear straight across. X. So I'm going to mark that as 45. And then, does the 32 have a vertical angle? Yeah. That one is vertical here with HG. That's not a proper way of naming it, but I did. All right. And then it looks like this angle is also going to be vertical with this one, but I don't know what it is yet. Okay, so how can I figure out what that is? Would that make a straight line, that pink line, the pink curve? Which would be 180, right? So if I did 180, 45, 45, 9, so minus 90, which is 90, and then minus the 32 is going to give me 58. So I could say this is 58, and this is 58. So now I haven't even looked at the questions, but I found out all of it. And another little extra piece, if I wanted to add up, this makes a circle, right? So those should add up to be 360 degrees. All right, so let's see. The measure of AXC. Let me erase these slides. So now it's just a matter of reading it. A to X to C. So all of that, well, I already know that's 90 because I labeled it. 90 degrees. All right, number 9 is GXF. Here's G, here's X, here's F. So it's that angle. It's 45 degrees. HXA. Angle HXA. Is this one? I found that one already. It's 58 degrees. And then angle FXD. F to X to D. Oh, I don't know this one yet. I have to figure it out. Which just means I need to add these two together, right? So 45 degrees plus 58 degrees is going to give me 103 degrees. Okay. Measure of angle AXB. A to X to B is this one. I already have it labeled. It's 45 degrees. And last, BXE. BXE. It's all of these. So I do need to add those up. 45 plus 32 plus 58, and that is 135 degrees. So you can do this type of problem by the way I just did it this time, by starting with what's given and then see what you can figure out from there and just labeling everything. Or it could have taken the given information, labeled that, and then gone question by question and find it one piece at a time. Both ways are effective ways to solve the problem. So it's really just up to you. Do you have an assignment in the online textbook 1-3B?